Hi, I'm Sharon Mackless at IDG, here with episode 67 of Do More with R, Astonishingly Easy Mapping with the MapView package. R has some excellent mapping options. There's the Leaflet R package, which I use when I really want to customize my maps. There's TMap, which I like a lot for its nice balance between power and ease of use. And recently, I've also started using MapView. Like the Leaflet package, MapView uses the Leaflet JavaScript library under the hood. What makes MapView a little different is that it's specifically designed to generate useful default maps with very little code. And I mean very little code. One function, 2 arguments, done. That makes it super easy to explore geospatial data. Plus, it has a couple of cool syntax tricks I'd like to share. For this demo, I'll use a shapefile of US states and data about population changes by state in the last 20 years. If you want to follow along, you can get links to the data either in the Associated InfoWorld article or the YouTube description for this video. In this code, I join my file with state borders with the population data. You can see the structure with dplyr's glimpse function. This single line of code is all I need to create an interactive map to explore my data, colored by percent change between 2010 and 2020, the column I specified. But please notice what's not here. Notice that I didn't have to specify in any way that these are polygons or that I wanted this colored by polygon. MapView figured it out. The MapView function only needed the data set as the first argument and the zcol, the column I want to use for the fill color, as my second argument. That's it. If I hover over a state, I get the zcol value. If I click on a state, I get a pop-up with all the data fields about that state. Now, that's probably not what you want an end user to see, but it's great for exploring your data. That pop-up is customizable, which I'll get to in a bit, but for data exploration, you get all this built in without having to say that you want rollovers and pop-ups. That feature ID as the pop-up title, by the way, comes from the data's row names. If your data set doesn't have row names, you get the row number. If you add row names to your data set with base R's row names function, you'll get a better table title. Notice now at the top here it says Louisiana and not what looks like a random number. By the way, if your table doesn't look nicely formatted like this one, try updating GDAL on your system. I updated my RGDAL package and it solved a table formatting problem. Let me switch from my slide to a full browser window so you can see something else. If you look carefully at the top left while I move my mouse around the map, you can hopefully see some text showing the longitude and latitude of where my mouse is, as well as the leaflet zoom view number. Bottom left shows the map scale in kilometers and miles. Also, if you look carefully, you should see a button at the bottom right with the name of my data set and column. If I move the map around or zoom it, and then I click this button, it'll take me back to the map starting point. Adding points to a map is just as easy as adding polygons. For points, I'll import a CSV file of state capitals with their longitude and latitude. If you want to use points data like this for GIS work, you'll need to turn this into an R spatial object. And this isn't only a MapView thing, it's an R thing. The SF package's st as SF function does this for you with data as the first argument, defining which columns have longitude and latitude in the second coords argument, and then a CRS projection used by a lot of background map tiles as the third argument. Now I can add my points layer to my polygon map with the plus sign and the same MapView function. Again, I didn't have to tell MapView these are points, it knows. In fact, it knows from the SF object which columns to use for latitude and longitude. I don't have to repeat that. In fact, once I've created a MapView object, I can just add another layer with the name of the SF variable. Sometimes you don't even need to call the MapView function at all. The start watching function will automatically map any SF object you add to or change in your R session. I'll need to show you that inside RStudio. Let me load my libraries and then use the Start Watching function. Keep your eyes on the bottom right panel. This will pop up whenever you start the function. Don't erase this and clear it out because you'll then ruin the stop watching. All right, now let me load a geospatial object in here. And you'll see it's automatically mapped. Now I'm going to do a join and remove the initial data. And you'll see that it's just showing the data with the 48 contiguous states. Now I can create another geospatial object. Let's say I just want 3 states. They're both here. I can go to my layers option, turn off the all data to just see that. Or if I remove the first data set, there it is. I can even create another variable with just one column of data and Start Watching will know that I want to color by that data. And to stop all this from happening, I just use the Stop Watching function. If you want to customize the default colors and opacity, there are arguments for that. Color for polygon boundary lines, col.regions for polygon fill colors, and alpha.regions for opacity. Here's an example where I use the greens palette from the Arc Color Brewer package and set the opacity to 1 so it's not transparent at all. The palette only has 9 discrete colors. MapView complains a bit that I didn't give it a ramped palette over all my values, but it does the work itself. If you're not familiar with the Arc Color Brewer package, it has a number of very popular palettes for map making. You can use one of Arc Color Brewer's diverging palettes in your map too. Here I'm using the red to yellow to green palette, but you can use any available palettes or make your own. Also for customization, you can rename a layer with the layer.name argument if you want a more user-friendly name on the legend, the bottom right button, and in the layers option, which you can see here. Now to a couple of those tricks I mentioned at the beginning. Here I'm creating 2 maps, one for the 2010 to 2020 population change, and the other for 2000 to 2010. I'm using my greens palettes and giving each map layers new names. You can place the maps side by side and have them move in sync with the Leaf Sync package and the sync function. Notice if I move the maps around or zoom them in and out, go them back to home, they move in sync. Or you can put 2 maps on the same layer and have a side-by-side slider to compare the 2. That is also super simple if you load the leaflet.extras2 package, just the variable name with one map, that vertical line symbol here, and the second map variable. It was this elegant and easy syntax that first drew me to MapView. You might have noticed here that one of these maps has a dark background. That happens automatically when MapView determines there is a lot of light areas on the map and it might look better with a dark background. But you can stop that by setting the MapView option basemaps.color.shuffle to be false. As you might be guessing now, there are a lot of other ways to customize your maps, either within the MapView function or by setting global session options. You can turn off legends, hover labels, or pop-ups altogether by setting any of those options to false. Now there's nothing here. You can also customize your map's projection. It's sometimes useful to show Alaska and Hawaii as insets instead of where they actually are geographically for a more compact map area. A few R packages generate a map like that, including Albers USA. The first lines of code here join an Albers USA map with some new data. But if you look at my MapView map, it's still using the default background tiles. And I don't really want Alaska and Hawaii over Mexico. But if I tell MapView to use my data's native projection, it'll automatically turn off the background tiles altogether and show a properly projected map. I can customize my bin breakpoints with the @ argument Here I'm setting breaks using base R's sequence function, going from -4 to 20 by increments of 2. The map follows suit. You can customize your pop-ups and hover text using the same techniques as with the Leaflet R package. I don't have time to go into this in depth, but it's explained in the accompanying InfoWorld article. Or pause the video and look at the code, it's not complicated. Using the custom pop-ups and hover text is very easy with the pop-up and label arguments. And now you can see these are customized. MapView isn't a general purpose data viz library, but it will actually also generate a scatter plot of a data file with 2 continuous numeric variables. And you've even got the hover text. One of the most important things you'll probably want to customize is your color palette. If you've got a favorite, instead of inputting it every time you draw a map, you can set a vector.palette argument. Here I use base R's color ramp palette to create a real palette function from the 9 colors in that R Color Brewer Greens palette I liked. This creates a palette function from those colors, since different maps will need a different number of colors. Now when I create a map, it uses my default palette without me having to specify it. There are a lot more options that you can set. Check the MapView options help file. But a reminder that most of what I just covered is nice to know, not need to use. I don't want to leave you thinking this is a complicated package. Remember, you can do your exploratory analysis of geographic data with a single short line of code for polygons, for points, including visualizing points by their attributes, such as changing their size based on your data. If you want to find out even more about MapView, package creator Tim Appelhans gave a workshop last year, and the videos are available on YouTube. That's it for this episode. Thanks for watching. For more R tips, head to the Do More with R page at bit.ly/DoMoreWithR, all lowercase except for the R. You can also find the Do More with R playlist on YouTube's IDG Tech Talk channel, where you can subscribe so you'll never miss an episode. Hope to see you next time. Stay healthy and safe, everyone.